All right, good morning, students. Our first lesson this week is called Keeping Balance, and I want to know what you think of when you think of the word balance, and how do you keep balance in your own life? So we're going to talk about how the Earth keeps its balance. We're going to look at these big global cycles related to what is going to keep the balance for global warming or climate change, noticing that from our lessons from last week, we noticed it is a little bit out of balance. So we're going to look at some of those potential causes. And I like when you can draw an analogy to your life. So be thinking about ways in which your life is balanced. Maybe, for example, do you wake up and eat a healthy breakfast? Do you take time to take breaks between your online classes? Things like that. Okay, so if you're ready, let's dive in. So the introduction says, where is the carbon dioxide coming from? Carbon dioxide is an important atmospheric greenhouse gas on Earth. Carbon dioxide seems to be associated with the most recent temperature rise on Earth. In History Repeats Itself with a Twist, you saw that temperatures on Earth have risen rapidly. In finding the cause, you learned that the culprit is carbon dioxide gas. But where does the extra carbon dioxide come from? And this is like kind of a dark picture of Earth, I guess. Kind of yellow. I don't know. What are the sources and sinks of carbon dioxide? So a sink here being where it is deposited, and the source is where it comes from. Understanding where carbon cycles throughout the planet will be critical to understanding interventions to the problem of rapidly rising CO2 levels. Investigate the diagram to the right. Is it an analog to CO2 in the atmosphere? Or it is an analog, or something that is similar to or shows the same process of what happens when CO2 is in the atmosphere. In this example, the faucet is a source of water in the bathtub. What happens to the water level in the tub if I open the faucet further and water enters at a higher rate? Will water levels increase? So here, let's look at our diagram first. We have the water bathtub and its components. We have the sources of the carbon, which is the faucet, fossil fuels, and deforestation. That's like cutting down trees. Why would that be an increase of carbon to the atmosphere? Because that carbon no longer is in the tree, it's then in the atmosphere. Right now, size of faucet is much larger than drain. So then CO2 is piling up and the drain runs faster. Then the sinks of carbon, or the drain, are land uptake or ocean uptake. So the places those carbon can go is the land and the ocean. So what would happen if I increase the faucet? The water level would increase and continue rising. The water level decreases. The water level decreases. Or does the water level decreases but eventually reaches stability, or water level increases but eventually reaches stability? Well, if you if you keep the faucet on and it's at a higher rate than what's leaving, the water level is going to increase. Okay, so you may think that, but in reality, if you increase more water, then more water is going to leave. And that's what this note says here. As CO2 piles up, the drain runs faster. So the more accurate answer is, water levels will increase but eventually reach stability. So here it says, opening the faucet increases the rate of flow, but as the water level increases, the drain flows faster, so eventually the water level will stabilize. Now imagine the faucet is pouring CO2 into the atmosphere. The rising water tub in the bathtub analogy would still be true if we made the drain smaller, causing less CO2 to leave. Imagine this bathtub has many faucets, each flowing CO2 into the atmosphere, or the tub, at different rates. Each of these faucets is a CO2 source. What process might also be a CO2 source? Okay, so go ahead and select which ones you think of these are a source. Careful though, because once you select it, you can't unselect it. So make sure you're accurate in your hypothesis, although you're not going to be graded on whether or not that's right. But going through which one of these would actually put CO2 into the atmosphere? Volcanic activity, chemical weathering, photosynthesis. Would it put CO2 into the atmosphere or take it out? That's what you're thinking. Cellular respiration, fossil fuels, deforestation, cutting down trees, or reforestation, planting trees. Okay, next. Let's investigate the bathtub drain. In this example, the drain removes water from the bathtub. What happens to the water level if the faucet is on and I make the drain smaller instead of the drain running faster as stated in the image? So if this is smaller, what's going to happen to the water level? The water level would probably increase and continue to rise because it has nowhere to go. So now we're looking at imagining the drain is pulling CO2 from the atmosphere. The rising water in the bathtub analogy would still be true if we made the drain smaller for CO2 to leave. But imagine this bathtub has many drains, each pulling carbon dioxide from the atmosphere at different rates. Each of these drains is a CO2 sink, which removes CO2 from the atmosphere. Now let's imagine some of those sinks are. Analyze the list to the right. Okay, so now you can change it. Which one would actually be a sink? And that's my guess, is these having trees to take up by photosynthesis is going to actually sink that CO2 into the land. Oh, and then let's take a minute. Maybe write down in your notes, because this may be new vocabulary for you. Chemical weathering is the breakdown of rocks through chemical exposure, such as water, oxygen, carbon dioxide, and acids. This exposure will alter the chemicals in the rock. So if you have CO2 trapped in the rock, what would happen if it weathered? Where would that CO2 go? And I guessed it would go to the atmosphere, so that's why I said it was a source. All right, now we get to look at some of these sources and sinks into three big categories. Anthropogenic, we should know this word by now. Anthro meaning man or human caused, genic, generated. Biologic or geologic, so from life or from rocks. Click the photos for each of the categories to learn a little bit more. Once you've explored these categories, sort the sources as either anthropogenic, biologic, or geologic. Okay, so let's start with anthropogenic. Okay, let's start with geologic. Here we go. All right, what do we got here? Okay, so let's see. This is a cool little program. We get to move around some variables. So we're going to reset all the variables down here. Reset. Observe the carbon output at the end of the timeline. So what do we see carbon in? Do you remember what ppm means? That's parts per million. So there's 50. Okay, so at time year 50, there is 615.5 carbon parts per million. And then we're going to increase the volcanic activity and see what happens. And now it went up from 615 to 636. So is that carbon a source or a sink? That would be a source because it's increasing the carbon because it went up. All right, so let's reset. So, and then maybe we want to, well, let's wait to add this to our observations till we look at all these different factors. Okay, so we have volcanic activity. When it went up, carbon in the atmosphere went up. Let's increase the amount of chemical weathering and then relook at the end. Oh, look at that. So, okay, remember our baseline is 615.5. Let's remember that. If I increase chemical weathering, this goes down. So actually chemical weathering would be a sink. All right, reset. So then our result is for, let's just do volcanic activity is a source. Next. So here it says volcanoes, while they can temporarily increase the albedo of the planet and cause cooling, it will release carbon dioxide into the atmosphere. And remember, increasing the albedo is more reflection, and if more light is reflected, then less light is absorbed, and that would cool the planet. Okay, so I'm going to take a note of that. Volcanic activity is a source. Okay, and then we just did that chemical weathering. So it says it's a sink. Chemical weathering is the result of CO2 in the atmosphere reacting with H2O and producing carbonic acid. This acid will dissolve rock, and the solution will leach into the soil, where it can be held for years before being re-released into the atmosphere. Oh, okay. So that makes sense. So that CO2 is now held in the rock, even after it reacted with water, produced carbonic acid. So that is a sink for CO2. Okay, let's look at cellular respiration. So we reset geological factors, and now we're on biologic. So if we increase the respiration, right, so now I want to increase respiration, and I notice that, let's reset. Let's look at our baseline. Oh, baseline's still the same. I increased respiration and it went way up. So cellular respiration is a source. And of course that's because we're releasing CO2 as a byproduct of metabolism. Okay, let's reset and then look at photosynthesis. If we increase photosynthesis, carbon goes way down. So that would be a sink. That makes sense because plants use the carbon dioxide in the air to make sugars. Here it says, keep in mind that an increase in photosynthesis means there are more plants on the planet. More plants equals more food for those organisms that use cellular respiration for their metabolism. More food equals population increase and vice versa. Therefore, these two variables are in lockstep with each other. If one increases or decreases, so does the other. So that's kind of what we're getting at with this whole balancing act. So you can change one, but it is going to have an effect on the other. All right, and let's test our final thing, anthropogenesis. Cool. All right, so deforestation, when I increase deforestation, that increases, so that's a source. And it says here, deforestation removes vegetation that absorbs carbon dioxide, while the reforestation will place vegetation back on the surface. So we can see that probably if we reforest, that's going to lower from 615 to 498. Reset. And then let's look at what happens when fossil fuels increase. That goes up a lot too. Okay, so fossil fuels are a source. All right, so now we've completed all three. Okay, so now they want us to go back and actually plug in some of those numbers, which is cool. So volcanic activity, initial output, if we increase it, it's going to go up to 636.6, and then go ahead and calculate that change. Okay, and then do the same thing for chemical weathering. So we're looking here now at what is the amount of increase. That's going to give us a little bit better idea of how big of a factor each one of these things are. Okay, so 595.9 minus 368 is, okay, let's go ahead and check that. Okay, so I guess on this slide, I don't know where they told us, oh, if we read the instructions. Okay, read the instructions. That is important. So we're trying to look at this over a 100-year time period. So now we need to change the time span, years, to 100. So let's go ahead and recalculate that at 100. So if we reset this, then we we start at 368 and I increase the volcanic, we're going to do volcanic activity first, and then I can see the final 900.2. Go ahead and calculate that, subtract out these two numbers, and then we'll do the same thing for chemical weathering. So reset this number, increase chemical weathering, 809.9. Do your math. All right, kiddos, so here's what we have to do. Read the instructions. You're resetting all values. Do not change that volcanic activity. Okay, so basically what we're trying to figure out is what will happen if the volcanic activity is the only thing that's at play here in this whole ecosystem. So set everything else to 0, and then even the chemical weathering, and then measure out 100 years. What do you predict to happen? So we go from 368 to 372. The change there is 4.7. And then we'll do that same thing for chemical weathering. So reset these values, set volcanic activity to 0, and then measure out 354.1. Calculate your total change. It drops, so that's negative. And that makes sense because chemical weathering is a sink, volcanic activity is a source. So you would expect CO2 to increase for volcanic activity and CO2 to decrease for chemical weathering. Woohoo! So now that we figured that out, let us do it for the other ones. So we made our prediction, but now we want to figure out what's going to happen over 100 years. We measure that final CO2, set everything else to 0. Okay, and then we're just looking right now at respiration and photosynthesis. So let's see what these instructions say. Do not change any biological factors. So because these two relate to each other in that lockstep like they talk about, we're going to leave both of them as equal. And yeah, so our final CO2 368, net change then is 0. Excellent work. All right, now what is it wanting us to do here? Based on your observations, set your initial impressions. Use the slider to assign a value for the contribution to the CO2 budget in the atmosphere. 1 is considered minor, 10 is considered major. Choose a value between 1 and 10. Okay, so I'm gonna estimate minor, just because here, if they're both equal, the impact is really nullified. All right, and then let's look at our final one, which is anthropogenic. And again, we're doing the same thing, so we're going out 100 years. We're going to set all these to 0. And then we're going to test individually one by one. So let's start with fossil fuels. We'll set deforestation, reforestation to 0. We'll measure our final 823.9. And go ahead and do your math. Maybe challenge yourself to do it without a calculator. All right, so if you did that, that's your number. And we'll do the next one. Okay, we have reforestation. So fossil fuels goes, well, let's reset everything. Fossil fuels goes down. Deforestation goes down. I guess how does this work if reforestation is? Let's look at our instructions. Do not change, okay, so do not change the value of deforestation. Repeat these steps for reforestation. Okay, let's do deforestation first. Reset. Fossil fuels goes down. Now we just have deforestation. We're at 419.7. Okay, go ahead and try to do this mental math. 419.7 minus 368. 51.7. 100. Okay, and then reforestation, my guess is that it's going to be null because let's reset these values, go back down. 368, 368. There we go. All right, cool. So we've done all three categories. Okay, and based on these, let's, we're just trying to rate our total. So go ahead and based on your numbers that you have built up here, how big of a contributor do you think? Volcanic activity, chemical weathering, biologic, anthropogenic. My numbers aren't showing up here because I've skipped around a little bit, but hopefully yours show up, and then you can go ahead and make an estimation based off that. So, and then we're going to use these results from the screen summarized below, add together the contributions of each one. So go ahead and add up your numbers there. And here is, so here, this is a good thing to add to your observations. Go ahead and write a little note about this. And maybe you want to say the biggest, you can analyze it, the biggest contributor to atmospheric CO2 is anthropogenic at 507.6 parts per million over the next 100 years. Okay, add that. That's going to help in our Blue Planet report later on. Here it says, while there are many sources of CO2 in the atmosphere, the major contributor is from humans. The anthropogenic category has the highest emissions and the highest projected impact on the CO2 budget of the atmosphere. And they're just using budget here as a way to say, kind of like the scorecard, like keeping track of all of the CO2. You would keep a budget of your money, and that would keep track of your money. Putting it all together. All right, let's go ahead and summarize it all up. Carbon dioxide comes from sources and is stored in sinks. The most important contributor is wild animals. Nope, probably human activity. All right, well done. It's evident that carbon dioxide is the cause and human activity is the major source of the increased carbon dioxide we see in our atmosphere today. Given that levels of CO2 are out of balance, what can we do about it? Over the last 100 years, a noticeable trend in global temperatures has been observed. It appears that this increase in global average temperatures has anthropogenic causes. Humans are contributing to the rise in CO2 in the atmosphere. The rapid rate of this rise is altering the effect of the greenhouse effect on the planet. Can you recall what the greenhouse effect is? Imagine walking into a greenhouse. It's really warm because the glass traps in the sun's rays. That glass is an analog or an analogy to the molecules up in the atmosphere, like CO2 or water vapor, like we explored in our last lessons. The temperature is increased at a rate much faster than has been observed at any point in geological time. Remember, we compared it to the other time where it has increased a lot, the Paleocene, Eocene thermal maximum, and it's even faster than that point. There are a number of mitigation strategies, mitigation being a way to reduce or balance out the amount of CO2 put in the environment or into the atmosphere, to limit and reduce CO2 in the atmosphere. What are these strategies and which will be the most effective in reducing CO2? How hot is too hot? Before you continue, take a moment to open your Blue Planet report and finalize 3 things. Your assessment of climate change / what you've heard about climate change, your analysis tab, and your synthesis tab. These items will be locked once you begin lesson 6 and cannot be changed after that. Okay, so that's because we've collected a good amount of our information here, so go ahead and open your Blue Planet report. That's up here in the corner. You can revise what you know about climate change, so you should have you should have typed out here a paragraph. Climate change is. And then maybe you want to note some of those pieces of evidence that we looked at. So increased temperature. And then maybe say due to. You talk about some of those factors. Okay, so we're moving on to the design in the next lessons, but here's what you want to have finalized. So again, you can look at your observations right here, and then you can pull observations that help answer that question, why is the planet blue? You can pull those pieces of evidence in. And here we had a conclusion that said, oops, liquid water makes Earth seem blue from space. This is possible because of Earth's greenhouse effect, a natural process that is caused by the presence of an atmosphere. Is Earth changing now? So we looked at some of these pieces, such as land and ocean temperature compared to a baseline. Here we have the glaciers retreating, and maybe you put in that coral bleaching and finalize this. There's a significant amount of data showing that the average global surface temperature is warming, glaciers are melting, average global sea temperature is warming, and coral reefs are experiencing bleaching. All right, so what happens when the temperature changes fast? So let's go ahead and see which one of our observations. Oh yeah, this one would help. This was talking about data taken from satellites, looking at the bleaching that happens in different alert levels. Maybe we want to include something about the PETM, the thermal maximum. So which one of these? Temperature trends across time, so I'm going to include that one. And yeah, and then I want to include this one too. This one's showing the rate of increase and when it peaks. And the conclusion here being, during the Paleocene-Eocene thermal maximum, when global surface temperatures spiked, we observed temperate forests temporarily migrated towards the poles, insect herbivory temporarily increased, and coral reefs collapsed. The rate of temperature change was slower than today, meaning that these historical events likely underestimate the impact of today's increasing temperature. So in addition to some of, notice how there's only 3 places for observations. You might select some of those other observations that, like for example, when we looked at the leaf analysis, or we looked at the insect analysis, those would be good things to put in here as well. Okay, so yeah, go ahead and then just summarize 2 to 3 sentences of the greenhouse effect, the changing planet, 2 to 3 sentences here, and then causes and effect. And you can then, same thing, put in some of these other, like, okay, here maybe I'll elaborate more on insect herbivory in this summary. Okay, so I'll let you go ahead and do that. To sum up, it will be locked after this, I suppose, so make sure that you're happy with your results, your conclusion from those 2 to 3 sentences. And from here, we'll move on to the next lessons, which will be designing, kind of taking a creative approach here to figuring out, like, how can we actually create solutions for this problem? I know for me, that's like, I don't know why my recording stopped. I don't know where it stopped. Shoot, so I'm going to repeat what I just said. Yeah, go eat a healthy meal, get balance from your life to fuel your brain so that we can go do the creative process of solving this issue and finding some creative solutions. Okay, awesome. See you guys in the next video. Ta-ta.